Hi, I'm Chris. I work for Testmeter, and welcome back to Talks with Testmeter, our podcast about all things test and measurement. Today we're discussing the hidden cost of power and why measurement matters, and it's only natural that today we have Elliot Ajose from Chauvin Arnoux to join us. Welcome.
Thanks for having us.
Rising energy costs are actually very prevalent in the media, as we all know right now, due to many reasons. And the discussion today, we're going to be talking around why energy matters, what is causing a rise in energy costs apart from the obvious, and how we might be able to reduce those costs.
Yes, well, it's a big topic. As we all know, energy today is becoming increasingly concerning from one level, but not only that, more demands, they're putting on the network for load parameters are becoming ever increasing. Net zero is something that everyone's moving forward to, a more sustainable future for us all. And the demands that are being added to the network obviously need monitoring. So hence why we're having a chat in further.
With the rise in energy costs, is there anything that businesses should be doing other than obviously just watching the amount of energy they're using?
There is stuff that they can do. They can reduce their energy consumption, and not only that, add passive or active harmonic filters for filtering harmonics. They can also do power factor correction, and without logging this data. So we have kVA, which is the actual total bit that is being utilized and being used by the consumer. We've got kVAR, which is the reactive energy, and the kilowatts, which is the actual bit that's doing the actual work. Now, the kVAR is totally wasted energy, and we can, with our units, we can log that data and see, especially when they've got a big demand, we can actually see, is it economically viable to be able to fit that power factor correction and make a unity power of 1.
Right, okay. So most people listening or watching this podcast might be used to paying their bills in kilowatt hours.
Yep.
If I remember correctly from college, industry, commercial premises, they're charged differently. And that's really where these sorts of nitty-gritty power measurements tend to matter. So with a few of the areas that you've just talked about there, what might that look like on site in terms of how equipment is running?
Power factor gets destroyed with capacitive loads. Now, the load parameters, this could be, we've got different types of load: capacitive, inductive, and resistive. And everything else is a non-linear load. Now, if we have a capacitive load, the power factor may be getting destroyed. So you can add capacitors and various other stuff that then bring that up.
Okay.
And make it better, basically.
Right.
So from a consumer's point of view, if you're spending X amount of money, they want to see a return on their investment. So buying a power and energy logger, they can then get a return on their investment. If their bills are £1,000 a month, they can then calculate, am I getting a return within 6 months? Or, we all want a return in business, don't we? So they can then look at that and see if they're going to get a return over a period of time, and how long, if they have no power factor correction, how long that will take to get that return from the actual spend on the equipment.
Okay, great. So again, in how that physically looks on site, what we're talking about here is we might have two very similar plants that belong to the same company. One plant might be using X amount of energy, the other plant might be using far more energy. And the plant that's using far more energy, that could be actually down to equipment failure. It could be down to problems with the supply. And that's really what we're talking about here. So like motors that might have failing bearings might have more reactive power, I guess, because there might be more heat losses rather than it going through.
It's exactly that.
Right.
Yeah. So it's an ongoing concern today. The amount of energy. If you are a big commercial site, you could have one site, exactly how you say, that is spending £10,000 a month and has a power factor of 0.7. So they're wasting 30% of their energy due to exactly what you're saying. That down to losses and stuff like that. And it's kVAR, reactive power, that's wasted in heat and various other stuff. Now, to mitigate that, customers buying a power and energy logger and actually logging that, and then they can see what they need to fit to be able to mitigate those issues. Not only that, you can isolate if there's stuff that's having issues itself, certain pieces of equipment, you can put it around the 3 phases of that equipment if it's a 3-phase load, and then get the voltage for that as well. And then it gives you loads of data to actually isolate, where is this coming from?
Okay, that's really interesting. And I think right now, again, it matters more than ever. I've got some figures here. This is actually quite crazy that electricity costs now 40% higher than what they were in 2022. And I think that really kind of hits home how much people's bills have risen. And also now is the time to start considering what sort of things people can be doing using equipment like your Qualistar. So how might that look on site? I'm aware that Chauvin Anu obviously have the Pell Power Energy Logger range.
So we have two ranges in sense of we have a power quality range and also our Pell range. So it's that Pell is power and energy logger, and ultimately it trends data over a long period of time. However, it samples at a slower rate than what a power quality analyzer will.
Okay.
So it's really beneficial for maximum demand. So if you want to check if you've got enough headroom on a circuit, let's say, for instance, we are an electrician and we want to add more to that circuit to be able to check the headroom. Not only that, to preload surveys for battery. So if you want to see how much house is consuming, it's really beneficial for sites and moving forward to that net zero. However, we are seeing an overvoltage issue across the country at the moment in certain areas on the LV side. The ESQCR stipulates that you're allowed 230 volts plus 10 or minus 6 phase to neutral, so allowed 253 at our top end and 216 at the bottom.
Yeah.
If it exceeds that or goes below it, what we're seeing is PV inverters shutting down, EV chargers, which we all know would be absolutely livid if we woke up with our charged car not charged, and we'd be frustrated on that. So the units like the Pell can be configured to various different electrical setups. This can be single phase, it can be three phase, it can be split phase, and much more. Not only that, it could be DC as well. And where that's beneficial is if you're wanting to capture this data, if you're wanting to see if I've got an overvoltage before I'm fitting an EV charger or fitting solar. It can be costly once you've fitted solar if you've got your next door neighbour or someone on the same phase that is exporting as you're exporting and pushing that voltage above the grid voltage that's stipulated. And ultimately, you could install something, it could be shutting down. So you'd have a customer that would be frustrated as after the fact. So yeah, really interesting topic, and it's ever increasing.
Yeah, I think that's I think for all those reasons now, when we look at the people's requirement for energy these days is just absolutely crazy. And specifically at Testmeter, we've had so many inquiries about load monitoring, where something like the Pell has been an absolutely fantastic solution that we can offer to our customers. So moving on from the Pell, it's fairly basic in terms of data loggers. So you mentioned earlier on that it's got a slower sampling rate than the Qualistar. It still has its uses, the Pell range, for a lot of contractors. And I mean, like I said earlier, we're seeing more and more people looking to connect these things onto supplies to do things like to see whether their supply is going to be able to handle an EV charger, for example. And it can also be used, like you said, for load monitoring, so that we can have a look at like imbalances between phases as well, just to make sure that, if a premises has so much equipment connected onto one phase and not another, that's going to cost them a lot in energy loss as well, right? Okay, moving on to the Qualistar range then. How does that really differ to the Pell? Obviously, they look very different. First thing I notice when I look at the Qualistar is obviously the amount of information that you can see on the screen rather than on the Pell, which gives you quite a basic set of power measurement.
Yeah, so it's exactly with the power quality analyzers themselves, where they are fit in is issues. So if you're getting, they can pick up, I'll just brief over this, the issues today with energy are voltage sags and swells, transient spikes, high or low supply voltage leading to high or low current, harmonic issues, phase angle issues, when we've got those single phase loads that you were talking about, pulling down, separating, changing the phase, not balance loads ultimately, and also harmonics. I'm seeing neutral currents being bigger than phase currents currently. Wow. And this is down to something called tripling harmonics. Now, where the power quality analyzer range fits in is capturing this data and then fitting harmonic filters. Not only that, I'll talk about that a little bit more, because why would you have high neutral currents? So any balanced loads, if let's say, for instance, we've got 20 amps on L1, 20 amps on L2 and 10 amps on L3, we'd have 10 amps coming back down on neutral. Now, where the issues are is how we get more neutral current is because of the load itself. So if we have 10 amps on the third harmonic, which is 150 hertz, 9th, the 18th, and so on, the 21th in they're called tripling. What happens is they go in phase with each other, and it's called multiplication effect, harmonic multiplication. They go in phase.
We're really getting into the nitty gritty here, aren't we?
Yeah.
Okay.
They add up to each other, but the issue is if you lose a neutral, you have phase to phase voltages on the supply, and everything will be damaged on the site, which we're seeing lost neutrals.
Right. So we're not only talking here about hidden costs of energy, we're talking about damage to equipment.
Everything will have phase-to-phase voltages dependent on, if you've got three-phase incomer and you lose a neutral upstream of the neutral bar, you'll have phase-to-phase voltages on that equipment, which then damages it.
And so there's a safety risk there, right, as well?
And it's costly. If you've got loads of equipment on site, it's going to cost, some sites have hundreds of thousands of pounds worth of equipment, and for single phase equipment, ultimately if they lose that neutral upstream, that's going to have 400 volts and that'll be damaged. And so big issue today, and I'm seeing the complaints probably bi-weekly of people not understanding why that neutral current is so high, and it's just offering that extra support that we try to do and aid them around understanding why the neutral currents are high.
Yeah, absolutely. And just while we're on that, what sort of who are the people that you're having conversations with? What are the typical sorts of user that would use something like the Qualistar?
So it could be anyone from energy management teams. It could be any electricians. It could be engineers. It's really a broad spectrum of people that are generally looking at various different subjects, within the energy sector. Whether it could be isolating bad equipment, whether it could be identifying harmonic issues, or it's all reducing costs basically over a period of time. Sure. And it's very, very varied, the people that I speak to on a daily basis with who's utilizing our equipment.
So we talked about the sort of persona that might be using something like the Qualistar on site. How would something like this typically be connected on site?
So on site, you'd have CTs, Rogalski cores, which you'd open up and put them around the incoming supply, either at fuse side, and then we'd also connect the voltage leads, and it's that simple. So there'd be, depending on what unit you'd have, but you'd have L1, one for L1, one for L2, one for L3, neutral, and earth if it's an 8345.
Okay.
CA 8345. So very easy to connect. You can do it in minutes. And we have magnetic probes that allow you to put them on the breaker screw heads, or you'd have to make tails or some means of connection, whether it's buzz bar for the voltage side. But the CTs, you can do it non-intrusively.
Okay, so generally, just for anybody that wondering what a CT looks like, for example, the idea here is it's like a single phase clamp meter, but obviously it's flexible, so you can fit it around the components easily. You plug it into the Qualistar, and then your voltage leads are just like any normal set of voltage test leads. But you mentioned there that you've got magnetic probes for easy connection, basically.
Yeah, exactly that. So that's really easy to connect. You just take the consumer unit off if it's a house, and then you put it on the screw heads themselves for the phase to neutral.
Okay.
And then if you're on a three-phase DB, you do exactly the same, connect the CTs. If you're just doing maximum demand, you don't actually need to connect the voltage side. So if you just want current and you just want to see headroom on a circuit, you just connect the CTs round, set it to log, and then leave and come back and collect it.
Fantastic. Okay, so in terms of power measurements, obviously you always need your voltage and your current connectors together. So one thing I'd just like to clarify with the Qualistar range is once you've got the PQA attached on site, you've got all your leads and your current transformers plugged in. Does that unit need setting up on site, or is it best to do it before it's taken on site?
So it's really versatile in the sense that you can choose. You can either schedule a date you want it to start recording. You can either start it from the faceplate itself and actually press the buttons to get it started recording. Not only that, you can remotely log into our units, connect them to a Wi-Fi, and as we all know, it's costly today to send someone to site, and to be able to send someone to site once, get them to do a log, for instance, and then download that data remotely without removing it is a reduction in cost for any business. Which, if you're 5-6 hours away, we know that can be costly. So we've integrated stuff like Wi-Fi in all our units, not all of them, but the Pell range, the 113, and also CA8345. You can actually connect it to a network, which just reduces that time for the user themselves.
Okay, fantastic. And I'm also well aware this that they are intuitive. I would give you that. But I mean, in my experience, used to be an electrical contractor. If I was to take a Qualistar on site, yes, I think I could figure out all the connections. But I know for a fact that Chauvin Anu have like a really good knowledge database on YouTube as well, which we find technically fantastic to advise our customers and reference our customers to as well. But just to give comfort to customers as well, something like the Qualistar, we could always just go on site with a customer together and just make sure that they've got the right piece of equipment before they decide to purchase.
So we'd be willing to do that as and when. We've got myself down south and Zach in the north and various other people within the team that are open and willing to go out on site as and when needed. So
we're also quite flexible as well, because we have a hire fleet of test equipment. So I know we've always got Qualistar and Pell solutions on that hire fleet. And I think you're probably aware, but Testmeter offer a try before you buy package. So basically, customers phoning up, we can direct them if needs be with your assistance to the right piece of equipment, and then we can just loan it to them for a week just to make sure that they've got they've made the right choice before making that financial investment as well.
That's good, isn't it? The fact that your customers could try it before they actually made that purchase, and see if it's fit for their application or use case.
So Elliot, just while we're talking about the Pell range, I think one thing that we sometimes struggle with our customers is that there's a little bit of misunderstanding that the unit actually needs setting up before it's taken on site. So I'll give you an example. For example, in the past where we've hired these units out, and the customer's gone to site, they've just plugged it into the supply and literally left it, which is fine because a lot of people would assume that's what you need to do. But these units require some sort of initial setup before the electrician leaves site.
So we'd always recommend just having a quick look on YouTube. If you type in how to set up, like you mentioned, if you go to site and actually attach the unit and without watching something, then sometimes you might not be capturing the right data. It might well not be on the right configuration for the instance, the range. If they're on a 2000 amp range, for instance, or they're on a 400 amp range and they're trying to capture 2000, they may actually have to configure that unit before going to site. We always recommend it because the clock data is really important to see timing and timestamps for that. So configuration before, plug it into a computer, use Pell transfer software, which is really easy to use, and you can configure the unit with a click of a button.
Okay, so just talking about Pell transfer, it's supplied with the unit. It allows the technician to actually set that unit up before they go on site. Obviously, the correct supply parameters, the sort of load they want to be monitoring as well, and then literally it's a simple matter of just pressing go on a session and then coming back when they finish.
So you put a date in and time if you want to schedule it for a future date. You press start and then that'll load it to the unit. And then we have another bit of software which is DataView Core that allows you to click a create report button. It will then populate a report with all nice pretty graphs and stuff like that. You can put your company logo in and actually present it to the customer. Where this is beneficial is customers, it's a chargeable service for electricians in the sense of doing logging, and they can make a nice PDF report with their company logo to then present to a client with a click of a button.
Yeah, so for somebody that might be interested in adding this to their services, it is actually a revenue stream for a technician to offer as part of their services.
Yeah, definitely that. Everyone, all businesses want to see a return on their initial investment, and they can then charge for this service. Doing a log for someone, whether it's an energy survey log or a maximum demand, they could charge for that service and then get a return on their investment within a certain period of time.
Okay, and DataView Core is compatible with the Qualistar range as well?
DataView Core, yes. So DataView Core is all our power quality range, and with a click of a button, it then populates it into another bit of software that then allows you to edit and amend anything that you want. You can have a site location, who the user is, and then we could put a logo in there as well, print a report as a PDF, and it just makes it really nice and pretty for the customer themselves when you send it to them.
Of course, yeah. Okay. And while we're talking about Qualistar, we briefly talked earlier on about voltage transients. Can you talk to the audience a little bit more about those and what they are?
It's not a problem. So voltage transients, it could be a lightning strike with bad earthing. It could be, remember when we were kids and you'd rub your feet on the floor and create static? It could be that discharging through something. Okay. It could be in the secondary side on transformer, the lug end, the crimp end has actually got a bit of resistance there. It could be a cable's got a transient that is currently, sparking over. It's various different stuff. And what that does across the sine wave, it just gives you a quick blip. It's not only that, it can be switching of on the HV side, you see a little blip across the sine wave. So what the issues caused by this is nuisance tripping. If we've done all our IR tests and we've gone around and we can't find any faults with electrical insulation, but we know there's nuisance tripping happening irregularly. So the transient itself, we can then capture that data and then highlight that to the DNO that it's potentially DNO side.
Okay, and so basically what we're talking about here is a very small spike in supply voltage, which can cause issues with machinery.
Tripping, nuisance tripping traditionally. So breaker tripping and not knowing why that's tripping. Doing, electrician coming out and as we know, running time is very important for certain businesses. They need operation for certain equipment, and if you've got stuff nuisance tripping, then it's a cost to them.
Yeah, of course.
So capturing that data, you put a power quality analyzer on it and stick it on capturing transients, and it will then capture a little blip across the sine wave.
Okay, so we've covered voltage transients. What about harmonics now?
So harmonics, when we're talking about harmonics, the first harmonics is our fundamental frequency, so anything at 50 hertz. What we're seeing today is we're all chopping up sine waves, AC to DC, and what happens there is, you create harmonics. You create non-linear loads, not only that stuff switching on and off very quickly, say, for instance, switch mode power supplies, variable speed drives especially is what I'm seeing. And now with the power quality analyzers, what we can do is we can stick it on the network, capture harmonics, and then see what passive or active harmonic filter is needed to reduce those harmonics.
Right.
Harmonics will shorten lifespan of equipment. There's no two ways about it. It will shorten the lifespan. So it's really important that if you have a harmonic issue, that you capture it. And if it's tripling harmonics, it can become even more costly because if you lose a neutral, as mentioned earlier, it's going to be everything phase to neutral will be damaged. And could potentially cause fires, heating issues and cables, and resistance increases across the network itself. So over a period of time, harmonics cause issues.
Okay, Elliot, in terms of leaving this test and measurement equipment on site, let's discuss how that might look on the PEL series. Do these things have batteries that just last for, because I imagine a measurement period might be a day, it might be a week, it might be even longer. So I'm just thinking in my mind through how are these things powered?
We use the figure of 8 mains lead, which plugs into the bottom of the unit. Not only that, we have a power adapter that has a trailing lead. And once we connect it to V1 and neutral, so phase 1 and neutral, it takes that power from phase 1 and neutral, so and basically self-powering adapter that you can fit on it. And not only that, if you're leaving it on for a week, you can lock out the display buttons. If you're leaving it somewhere that you don't want it to be anyone to press any buttons, you can actually lock those display buttons out on the actual faceplate itself, so it can't be tampered with.
Okay, fantastic. And in terms of battery, can somebody just leave it on battery power if they don't have access to a voltage supply?
So you have to figure of 8 mains trailing lead. You have to use a mains lead for it. It has got a limited battery on the unit, but the battery itself is just to make sure the data doesn't go corrupt. If it loses supply and voltage, what will happen is it will capture the fact that it's lost that supply and keep logging the fact it's 0 volts. But when it restores, it will then continue capturing. But it does need power in the figure of 8 mains lead at the bottom.
So just thinking about some real world scenarios here. Say, for example, we have a factory with repeated drive failures. What might that look like in real world?
So obviously it's a shutdown of certain equipment. If you've got certain variable speed drives not working and operating as intended, it could be even HVAC systems, the air quality systems that are shut down, which is vital in certain in industries and sectors. It's absolutely vital. So what that would look like for the customer base themselves would be, hiring a unit from yourself or requesting you to come out on site with myself, and we'd go out on site and we would actually do the log and demonstrate the equipment on site itself in the live setting and find out what those issues are.
Yeah, and obviously in this example, it's going to be something like harmonic distortion. Those issues can be clearly identified using something like the Qualistar that we talked about earlier on, and repaired, and then obviously that's scenario one fixed.
So with the Qualistar range, what we have is a live data functionality within there. So if we go to a site, they can actually see that data live, which is beneficial. You might not have to do a log to identify bad equipment. So it just reduces the time that they actually need to be on site themselves. If they can hire a unit from yourselves, attend site and actually stick it on the live data, they can then see what harmonic order that is live.
Sure. So they're able to fix that failure on site, and they're also able to save money moving forward in their billing as well.
Exactly. That's all a reduction of cost, isn't it? And they can do that very easily.
Okay, here's a second example. A commercial building, typically single phase, some of them might be 3-phase, but the customer's experiencing high energy usage and load usage. How might that look?
So that would look same again, hire or purchase a unit from yourself, attend site, stick a log on and actually see what time these load parameters are. Are they out of hour usage? Is it down to certain equipment? They can isolate what the load of equipment is and see if stuff is drawing more than it's supposed to. So it does give them the flexibility for the users to be able to identify certain areas of high demand.
And something like this might not need the investment of a Qualistar either. It's quite a simple solution which the PEL can help with.
Yeah, I'd recommend the PEL for that sort of, if it's energy consumption and it's not those short-term issues or identifying harmonic issues and it's just load parameters, I'd recommend the PEL for that use case.
So a simple fix which equates to immediate savings for the customer.
Yeah.
Here's another scenario, a contractor user case. So they've gone on site, they've identified a power issue, and they now have the data on that Qualistar to back up that the power issue isn't down to the installation that they have created. It's actually down to a supply issue, which is not the contractor's problem.
Yeah.
So how might that look on site?
So once they've captured that data, they can then produce a report itself and present that to whoever they want. So how that would look is open the PEL transfer software if you're using PEL, or open the PAT3 if you're using 8345 or PAT2 software. You'd be then clicking create report button, making a report to then present to the distribution network operator if it's an incoming feed issue, or if it's an 11 kV ring and someone who owns that 11 kV ring, presenting it to the IDNO or whoever that is that owns that 11 kV side.
And that's giving the contractor added consultancy value, but it's also giving them extra reputation as well, isn't it? Because they're able to prove that obviously that
it's not
issue
their issue.
There we
it's
go.
not their issue, and ultimately there's lots of issues out there that may well not be down to the electrician. The first thing that happens, as we all know, is if stuff's breaking, electricians and engineers get blamed for that in some instances, and some instances are not down to electricians and engineers. So to have that data, without it, you cannot present anything. So it's really important to capture the data first, and not only that, for liability purposes. If you've got the data stored locally and you for each site that has presenting issues, and you've notified the DNO, then it's liability purposes. It's expensive, isn't it, if stuff breaks and the electrician gets pointed at first, unfortunately,
It's a big word, isn't it, liability, and it's something that you want to be completely aware of.
Of course.
So quite clearly energy costs aren't going down.
Yeah.
So would you say now that measurement is pretty much becoming a standard on site now?
I'm seeing it increase. That is certainly something I'm seeing, as far as the need to move forward to a net zero sustainable future that would make a better world for us all.
Sure.
It's creating a high demand for that, and everything electrification in the way that it's being adopted, and moving forward the way the UK plans to adopt it, is becoming an increasing topic which logging is required for.
Yeah, and I think there's also almost like a change in mindset where people aren't just waiting for a problem to happen and reactively fixing that problem, but they're proactively using tools like the PEL range, like the Qualistars, to identify these issues before they've even started.
I think it's exactly that. I agree. So downtime is costly, isn't it? As we all know, any downtime with a site is costly. And to reduce that, mitigate that moving forward, identifying it before it happens makes total sense. I mean, the main topic that I was just wanting to discuss today was that losing a neutral, the harmonic issue that I'm seeing people complaining of hot neutrals, down to the tripling harmonics. Now, capturing that date before it happens, you can save whoever the sites are, you can save them a lot of money around that. And
sure.
It's really costly. It's really costly losing a neutral upstream in the neutral bar.
Yeah.
So yeah, interesting topic and ever increasing.
So in terms of companies, obviously using packages like the DataView Core, they're able to clearly keep data on site. They can see trends in data over time as well, and they can actually adopt that as part of their energy strategy moving forwards.
So trends, it populates the data over a period of time. We have something called an aggregated period. And what that does, it gives us a minimum, a maximum, and an average over a period of time. Now, where that's useful is, say, for instance, you can change that after. It's still sampling every 1 second and capturing that data every 1 second, but it will show us over a whole window. If we leave it a week logging, it will show us what is the minimum it's been, what's the average it's been, and what's the highest it's been.
Okay.
Which for load parameters, we may well want to see it over a 10-minute period. If it's a voltage issue, we would care about it for 1 second because EV stuff switches off and PV inverters. So it really does depend on what you want to capture itself on, and basically it's interchangeable with the logging parameters that you can utilize for that, depending on what you want to present to what customer. And yeah.
Okay, fantastic. Well, thanks for joining us today, Ilya. I think it's been actually a really useful conversation. I think sometimes a topic surrounding power quality, when you really do boil down, it is quite a specialist subject. Admittedly, I sometimes find it quite dry, but I think you've put a really interesting and fresh spin on it. So I appreciate that.
Thanks for having us on.
No problem.
It's been good.
We'll hope to have you back again soon.
Yeah, look forward to it.